252 million years ago, Earth was a world alien to our imagination. A single supercontinent, Pangea, stretched from pole to pole. Its heart was a vast desert where sun-baked winds whipped clouds of dust across red dunes. Forests of Glossopteris, ancient trees with heavy, tongue-shaped leaves, flourished along the coasts. Rivers, like silver threads, wound through canyons, feeding swamps where giant amphibians croaked, and dragonflies with wingspans larger than a palm buzzed in the oxygen-rich air. Life had flourished for 300 million years. In the oceans, coral reefs, composed of sponges and bryozoans, glittered underwater like sunken cities. Trilobites, living fossils barely changed since the Cambrian, scurried across the seafloor. Nautiluses floated in the depths, their spiral shells reflecting the dim light filtering through the water column. On land, synapsids, the ancestors of mammals, ruled. Dimetrodon, with a sail on its back, basked at dawn, using its skin as a solar battery. Moschops, massive as rhinoceroses, leisurely browsed ferns. The sky did not yet belong to birds or pterosaurs. Only gliding lizards leaped from cliffs, skin spread between their toes like ancient hang gliders. This was not a world of monsters, but a world of balance. Ecosystems were complex, intertwined, resilient, or so it seemed. But deep beneath the crust, at the very boundary of the core and mantle, something ancient began to stir. A plasma plume of molten magma, hotter than the surface of the sun, slowly rose. It pressed on the lithosphere like a fist under thin ice. Where Siberia is today, the earth trembled. Cracks opened not with an explosion, but with a long, weary sigh. Lava flowed, black and glassy, spreading for hundreds of kilometers. No one noticed. Not the therapsids in Gondwana, not the fish in Tethys, not the microbes in the bottomless pits of the ocean, but the earth began to bleed. And with every drop of magma, it released something more terrible than fire. Carbon, methane, sulfur, toxic gases that would soon choke the sky, boil the seas, and obliterate entire branches of the tree of life. This golden age received no warning. There were no prophecies. There was only silence, and the first barely audible crack in the foundations of a world about to collapse. At first, no one noticed the change. Summers grew slightly longer, winters milder, rivers warmer. Animals migrated further toward the poles, distorting their usual routes. Plants bloomed out of season. It seemed odd, nothing more. But beneath the ocean's surface, something terrible was happening. Carbon dioxide emitted by Siberian lavas dissolved in the seawater, turning it into a weak acid. Corals and bryozoans, the builders of the great reefs, began to dissolve. Their skeletons, which had grown for centuries in the silence of the depths, now crumbled like chalk. Reefs, once teeming with life, became dead cemeteries of white stone. The air was changing too. The CO2 concentration doubled in a few thousand years, a blink of an eye in geological terms, but an epoch for living things. Forests suffocated. The ferns that had covered the continent for centuries began to turn yellow and fall. In their place, only hardy relics of ferns grew, modest, faceless, like a symbol of the approaching emptiness. And deep within Siberia, the eruptions continued. Lava flowed for years, decades, centuries. Each new flow released methane from permafrost and marine hydrates, a gas 25 times more potent than carbon dioxide in terms of greenhouse effect. The atmosphere began to overheat, like an avalanche. Temperatures on land jumped by 10 degrees. In the oceans, by 8. Life tried to adapt. Some fish retreated to the depths, where the water was colder. Land animals became smaller bodies, easier to cool. But evolution couldn't keep up. The climate changed faster than genes could mutate. And then the real story began. The oceans, overheated and deprived of oxygen, turned green. Cyanobacteria, ancient microorganisms that thrive in warm, oxygen-poor water flooded the surface. They released hydrogen sulfide, a poisonous, foul-smelling gas that poisoned all life. The wind carried it across the continents. Where birds, not yet born, had once sung, there was now silence. Where therapsids had scurried, only bones remained, bleached by acidic rain. The earth wasn't just sick, it was beginning to breathe poison. And every breath brought the end closer. When the hydrogen sulfide reached the upper atmosphere, the sky changed forever. It turned yellow-green, cloudy, like glass saturated with poison. Sunlight barely penetrated this veil. Photosynthesis slowed, then almost stopped. Plants died not from heat, but from starvation. They didn't have enough light to breathe. The oceans turned into giant cauldrons of anaerobic slime. Without oxygen, only hydrogen sulfide-producing bacteria thrived in the water. Billions of them colored the surface of the seas an ominous turquoise green. Methane accumulated in the depths, invisible, but ready to explode at the slightest disturbance. Sometimes it did. Giant bubbles burst to the surface, carrying with them the last remnants of marine life. Silence reigned on land. There was no singing, no rustling, not even a whisper. Only the wind, blowing ash and dust across the parched plains. The bones of the therapsids lay where they had fallen. No one came to eat them. Scavengers died out first. Even insects vanished. The air was too toxic even for them. The temperature did not drop. The greenhouse effect took a reversal. The more plants died, the less CO2 was absorbed. The less rain, the drier the land became. Deserts expanded, swallowing the last patches of forest. Rivers dried up in weeks. Lakes became crusted with salt and sulfur. And all this lasted not a year, not a decade, but hundreds of thousands of years. Geologists call this layer in the rocks the Permian-Triassic boundary, a thin black band, almost devoid of fossils. It's as if life on Earth had simply been switched off. Only a few survived this hell. Small, unpretentious creatures, able to hibernate or withstand toxic water. Some fish hid in underground springs. Worms and mollusks survived in the mud, where there was almost no oxygen. And on land, just a few species of rat-like reptiles huddled in rock crevices, feeding on the rotting remains of a bygone world. Earth became a ghost planet. But even in this hell, a spark flickered. Because extinction isn't the end, it's a reboot. Hundreds of years passed, then millennia. The lava in Siberia finally solidified. Volcanic gases stopped escaping into the atmosphere. Rains, light, acidic, began to wash the toxic dust from the Earth's surface. The sky, though cloudy, became slightly clearer. And then, almost imperceptibly, a miracle began. In one of the cracks on the shore of the dried-up sea, something green sprouted. Not a giant glossopteris, not a lush fern, but a modest plant with thin leaves and deep roots, able to thrive in poor soil, tolerating drought and poison. It didn't bloom, it simply survived. A quiet return was also underway in the oceans. The cyanobacteria retreated as the water temperature began to slowly drop. Oxygen returned to the surface layers, first in drops, then in streams. And in this water, new creatures appeared, small bivalves resistant to acid, fish with simplified body structures, not requiring much oxygen. They weren't beautiful, but they were alive. On land, the surviving reptiles, the descendants of those same rats of Perm, began to emerge from hiding. Their bodies were lighter, their breathing more efficient. Some began laying hard-shelled eggs to protect their offspring from dehydration. Others developed the ability to survive for long periods without water. These were not the great rulers of the world. These were the first builders of the future. Ecosystems were no longer complex, but they were resilient. One plant species leads to one herbivore species leads to one predator species. A simple chain. A lesson: the simpler the system, the harder it is to break. And gradually, very slowly, biodiversity began to grow. First, dozens of species, then hundreds. 1,000,000 years later, thousands. And 5,000,000 years later, entire new classes of animals filled the void. Among them were the ancestors of dinosaurs, the ancestors of mammals, the ancestors of us. The Earth has not forgotten the catastrophe. She learned from it. And the one who survived wasn't the strongest. It was the most adaptable to change. The world after the catastrophe was strange, not as majestic as before, not as diverse, but flexible. Each new species was like a rough draft, not an ideal, but an attempt. Nature was trying out forms that had previously seemed impossible. Ichthyosaurs appeared in the oceans, reptiles that had returned to the water, with bodies resembling dolphins, though dolphins didn't yet exist. Crotallosaurus roamed the land, giant predators with skulls studded with spines, but with clumsy bodies, as if assembled from alien parts. The sky was still empty, the wings hadn't yet been born. But amid this chaos of forms, something else was maturing. Small, light-footed reptiles with straight limbs beneath their bodies, not splayed out like lizards, but hunched like mammals. They ran fast, they breathed efficiently. Their bones were hollow but strong. Their hearts beat faster. These were dinosaurs, then still unnoticed, secondary inhabitants of a world ruled by others. The climate remained harsh. Pangea was still a single continent, and its interior deserts stretched for thousands of kilometers. But at the edges, near the oceans, new forests flourished: conifers, cycads, ginkgos. Here, in the partial shade, survived the ancestors of turtles, crocodiles, even the first mammals, tiny, furry creatures hiding under roots. Ecosystems no longer sought complexity. They sought speed, flexibility, the ability to start over if disaster struck again. Life became cautious, but not weak. And it was precisely in this caution that strength was born, because 10 million years after their extinction, dinosaurs will no longer be just another reptile. They will become the masters of the earth. But for now, they just run. Faster than the wind, faster than fear, straight into the future. Today, 252 million years later, the Earth once again stands on the threshold of change.